Again, you need to have your graphing calculator out, and then we're going to go through this. 7.1 is graphing exponential equations. So you're going to do this on your graphing calculator. On your quiz, you're going to have to sketch it. I will provide you grids on your on the quiz. Okay, I'm sorry. And then for your homework, one of the things that you can do is you can take pictures of the screen, of your calculator screen, and insert those pictures into your homework instead of sketching them. But again, on your quiz, to be clear, I'm going to provide you grids, and you're going to have to draw a sketch of your graphs on the quiz, okay? Now, here's the type of problems that you're going to be working on today, okay? You're going to be graphing them, and then you're going to state the domain and range. What makes these equations exponential equations is because the variable is in the power. That's what makes it an exponential function or an exponential equation. When the variable is up in the power, then that's an exponential equation. Okay. Now, so you can go ahead and type that into your calculator. A couple things I want you to be aware of. Most of you have a newer one, so when you hit that little caret button to make it do a power, it'll automatically superscript it. And so you can just type x plus 3 in, no big deal. If you have an older one, you might need to put the power in parentheses, bless you. So you might need to put it in like that to keep it all in the power. But if you have a newer one, you probably don't have to do that. And then to arrow out of the power, you just hit right arrow, and then it'll take it back down to regular. So go ahead and do that, and then we'll come back and talk about what the graph looks like. Now, here's what your graph should have looked like. Now, this is obviously on an app that I used, but this is the standard 10 by 10 window. Your graph should look like that, okay? If you are not in the 10 by 10 window, you can always go back to it by hitting the zoom button, and then number 6 is Z standard, and that'll take it to the 10 by 10 window. Now let me show you something, because we still need to find the domain and range. I'm going to show you something on your calculator that I haven't shown you before, and I'm going to attempt to do it. Now, so you're going to hit the trace button, which is right on top, okay? And you will get a little blinker that is actually on the graph, okay? And notice at the bottom of your screen, it will tell you the coordinates of that point. If you move to the right, hit the right arrow, it will move up the graph to the right. And notice that the X and Y values change, okay? Now, those are points on the graph. Now, I can keep arrowing up even though eventually I'm going to not be able to see that blinker anymore. And notice what happens with the X and Y values, okay? They both keep increasing because I'm moving to the right. The X keeps getting bigger and bigger and bigger, and the Y's are getting bigger and bigger, but quite a bit faster. And that's what should happen with an exponential function, okay? So the X's are creeping up to the right very slowly, but as I move to the right, as the X values increase,
where's your little thing?
Right, it's way up here somewhere, okay? It's the Y values keep increasing and keep increasing.
So they're increasing by a ton now.
Now, here's the thing. There's no limit to how high the Y will go. At the same time, there's no limit to how far right I can go on the X. There will always be an X value that corresponds to a Y value as I move to the right. Now, the same thing is going to happen when I move to the left. Now, I'm going to come back down much quicker to the left, and there it comes back. Now notice here, again, the X values continue to go down, and the Y values now start going slower. So when I was moving up the graph, the Y values were increasing very quickly. Now if you notice, the Y values are decreasing, but they're decreasing very slowly, okay? And in fact, it's getting close to what, but never actually getting there? -5. And that is not a coincidence, because right here we have this -5. And I'm going to talk a little bit more about why it actually will never get to -5. Now, you can keep going left, and eventually this number here will actually say -5 because I don't have enough decimal places. your graph only has a limited number of decimal places, and eventually when it gets to negative 4.9999999, it runs out of decimal places, and it makes it seem like it equals negative 5, and I'm going to explain to you why it never actually equals negative 5 here in a second, okay? Let me talk about why it never equals negative 5, okay? So the key is this value right here, okay? In order for y to equal negative 5, what does what I've circled in red have to equal?
0.
It has to equal 0. If that equaled 0, then y would equal negative 5, okay? Here's what's interesting. Is 2 to some power, okay? Obviously, if x is a big number, and I have 2 to some big number, I'm going to get a big number. So obviously, that's not 0, right? As I approach the power being 0, so if x was negative 3, what would 2 to the 0 be? 1. So any exponent with a power of 0 equals 1. Now, if these become negative, then it's just fractions, right? Because we have negative power, we move it down. There's no way that this value can ever be 0. I don't care what value you find for x. You can try every number in the world. 2 to that power is never going to equal 0. Okay? So the truth is that when I look at exponential graphs, they are going to approach a boundary. They're just never going to get there because this can never equal 0. Even though your calculator might display negative 5, it's because there's not enough decimal places. Because at some point it's got negative 4,999,999 and it runs out of decimal places, and so it's like, all right, I guess it's negative 5 because there's not enough decimal places. You'd need an infinite number of decimal places, and it would still never get to negative 5. Okay, so the key to all of this is that there's always going to be a corresponding x value, no matter which direction I go. Even though it seems like it kind of has a boundary here, I could pick this value, any value for x. It might be way out here. Its corresponding y is going to be way up there, but there's going to be one. Okay. The issue that we're going to have with exponential functions is that there's going to be a restriction on the y, but not for the x. And here's what that ends up looking like. Okay. So the domain for exponential functions will be all real numbers. There will always be an x. We have this boundary for y here. And when we talked about parabolas and quadratics, we had minimum and maximums, and they were greater than or equal to or less than or equal to. For exponential functions, it's not going to have the or equal to for all the reasons that I just explained before. It will never get to negative 5. And that's part of the reason I drew the boundary with a little space here. You would have to zoom in and zoom in and zoom in and zoom in to see that it would actually never touch. And it's, again, because this 2 to the power can never equal 0. It's not a coincidence that this number negative 5 and this boundary negative 5 are the same. Okay? So the trick is whether or not it's going to be greater than or less than. In this case, it's greater than because obviously all these values above this boundary are going to be y's that are included in that trace function. Kind of helped us figure that out. Okay?
So
Any questions on that?
Do we need to use the trace on like a regular problem?
No, eventually we're going to do this without doing any really, we're going to be able to pick the domain and range off right from the equation. And that's where we're going to get to today, okay? So, are there any questions about that before we move on to the next one?
No, sir.
So here's another problem. And again, in your homework, what you're going to do is you're going to insert this into your calculator. You're going to take a picture of the screen, and that's what you're going to insert for your sketch. I mean, if you really want to sketch it, you can, but I'm giving you permission not to. But go ahead and find the domain and range for this one after you've graphed it, and then go from there. Let's take a look, okay? Can we predict
Yes.
what's going to be the domain here?
All real numbers.
Okay, what do you think the range is going to be?
Y is greater than
Y greater than negative 3. So here's our graph.
Wait, why do you know it's greater than?
We're going to get there.
Because it can't be less than.
Why not? You tell me.
Because
Okay,
it
so,
cannot go.
okay, just hold please. Hold, please. All right, so I have this boundary here, and it looks like it hits -3, but it actually never does because this can never equal 0. Okay? So what my domain and range should be, all real numbers, y greater than -3. How many had that? All right, so here's what I want you to do on this problem. Before you graph it, I want you to try to write the domain and range. Then graph it and see if you're right. Okay, so go ahead and do that for that one. Obviously, there's some things different about this one than there were on the last one. And we'll see if any of that has an effect on the correct answers. All right, what's different about this problem that changes things, do you think?
It's a positive. So it would be.
What's negative?
Less. Y is less than 2 instead of greater than.
Which negative?
The
This.
2. Oh.
This negative in front. Okay, think about it.
It's gonna go down.
So right,
Not
think
hard,
about
so it's
it.
y.
Okay, think about when we work with parabolas. Okay, when the a was negative, it flipped the parabola over. Okay, so that's going to happen here because this first term is negative. This is the a. Okay, and so it takes the graph and flips it over, which means my range is going to be affected. Okay, the domain is still going to be all real numbers, but now instead of having a boundary and going above it,
Mine does not look like that.
we're going to have a boundary and we're going to go below it, okay? Which means the y in the range is now less than 2. So this number is still the same, okay? This number here still impacts the range. This number made it flip over, which means now we're less than 2, okay? So that's how those numbers and the signs of those numbers affect things. Let's look at one more. So that one, how many had the less than or greater than flipped originally? Okay. So now you know you got to look out for that number in front and the sign of that number. Okay. So how about this one? Go ahead and do this one. Again, try to find the domain and range first. Try to do it without the graph first, and then see if you do it right. All right, so we know the domain is going to be all real numbers. For the range, is it going to be greater than or less than? Okay, it's based off of the number in front. Is this positive or negative?
Positive.
Positive, which means it's going to be greater than. If this was negative like the last one, then it would be less than. So here's what your graph looks like. Now notice all these fractions, especially this fraction here, makes the graph kind of flatten out. Okay? But again, we have a boundary here at 1 and everything above that. So my domain is all real numbers. My range is y greater than 1. How many had that? Okay. And that's all 7-1 is. Okay. So again, for your homework, feel free to take pictures of the screen, insert that as your graphs, and then state your domain and range, and you should be good to go.
So it's literally